Welcome, everyone. I'm your moderator, John Yuva, editor for Supply and Demand Chain Executive and Food Logistics. Thank you for joining today's web seminar titled Supply Chain Transformation, New Requirements and Capabilities, sponsored by Software AG, an enterprise software company with more than 10,000 enterprise customers in over 70 countries. Before we get started, I want to encourage attendees to submit questions throughout the presentation using your ON24 control panel. Questions will be addressed during the Q&A portion of our event. Let's meet our speaker for today. Sean Riley is Global Industry Director, Manufacturing, Supply Chain, and Logistics for Software AG. Sean has more than 10 years of experience in the supply chain and logistics field. He has an MBA with distinction from DePaul University, is a certified Six Sigma Green Belt, and has been named a Supply and Demand Chain Executive Pro to Know for the 6th consecutive year. Topics covered in today's event include a new paradigm emerges for supply chain management, enabling supply chain transformation, changing supply chain capabilities, critical supply chain questions answered, and more. Without further ado, I'll turn the event over to Sean.
Thanks, John. Appreciate it. Thank you, everyone, for joining us today. I hope you find the webinar exciting and educational. Additionally, we'll have a couple of questions scattered throughout the webinar to make it as interactive as possible. So without further ado, let's go ahead and get started. So I came across this article the other day by Harvard Business Review titled The Death of Supply Chain Management. And I thought that was very interesting because of all of the attention that enterprises are giving to their supply chains. And the article focuses on day-to-day supply chain functions as really being obsolete, that the skill sets that are used today will not be around or needed in the future, and that we need to really begin focusing on a smaller group of supply chain professionals that have a very different type of skill set. And the reason for that is because of the new capabilities that are coming about. And as we look at supply chains, as well as the traditional siloed approaches, and I've just created a small graphic that shows the base function there between planning, execution, monitoring, and control. The technological changes that are coming about are going to really blend and mix these particular items together, requiring both fundamental changes to how we operate supply chains, as well as fundamental changes to what supply chains are going to be able to deliver now and in the future. And that blending is really going to show up in terms of the same functions, but those functions are going to be executed by a whole new set of capabilities, some that have already arrived, some that are arriving. And we're going to start discussing those new capabilities during this particular session as the linchpin for how do we begin to transform our supply chains, how do we ensure we're able to future-proof those supply chains, and how do we ensure that our supply chains are robust today and performant in the future. But before we get started, as John said earlier, Software AG is a IT technology company that provides services and technology to more than 70% of the Global 1000 and more than 70% to the Gartner Top 25 supply chains. We currently work with over 281 manufacturers in over 72 countries, and our technology is used as the platform of choice for several leading industrial platforms. So that's just a quick overview of who Software AG is, what we've done, and that the company has been around in this space helping manufacturers, retailers, and logistics providers formulate a functional end-to-end supply chain for many years. Now back to those technologies that we were talking about. We've all heard about multiple technologies that are coming to the forefront. The one I like to use the best as a great example is autonomous vehicles. They have a lot of hype. What if we could remove drivers from trucks, remove operators from fork trucks, and have those vehicles completely autonomous, completely working on their own? What would that do for a supply chain in terms of delivery or goods certainty? What impact would that have? We've already seen the impact of some technologies as they've come to fruition, such as collaboration hubs, and taking it one step further, the development of a ecosystem that fundamentally works with the enterprise and with each other to ensure continuous supply chain optimization. And then, of course, we've also experienced and heard about the value of IoT in the supply chain, from everything from simple freight monitoring to geoposition to leveraging data to understand the condition of product as it's being shipped in transit, to understand quality, to better understand any type of issues that might have occurred with that product in transit and make critical decisions before the product arrives. Other technologies that are just as important that come to fruition and really come into their own because of IoT in one sense and other technologies are complex event processing and, of course, predictive analytics, where predictive analytics allows the shift from demand planning to continuous demand and supply prediction based on real inputs as they're coming into the supply chain. So that while you can have a very long forward-looking plan, that plan is always being updated with continuous demand predictions based on changing variables as they occur. And then, of course, how do you tweak the plan when you know when your variables are deviating from when the algorithms were originally created? That's where machine learning comes into play and looks at exactly how those variables change when the algorithms are, or how the algorithms need to change that run that continuous demand prediction to enable a fluid and better working supply chain. And then on the action side, we look at both closed loop analytics and robotic process automation. So the outputs from any sort of event processing, event monitoring, or any changes that your continuous demand prediction might interpolate are automatically managed, and the exceptions are taken care of. So thus far, what the HPR article said in terms of the death of supply chain doesn't really mean that the supply chain is dying, or I should say the death of supply chain management doesn't mean that the practice is dying. It's just shifting. And the focus is shifting significantly from pushing data around to how do I plan to use data? How do I ensure that I'm able to plan and optimize my occurrences, my actions before I need to take them? And how do I make sure that the tools that I have at my disposal are going to act in the best manner possible based on environmental conditions, based on customer requirements, and based on stakeholder needs across the enterprise? And while that's still important, and while those technologies are coming to bear, and some companies have introduced some or all, and some have not, fundamentally, there's still very similar supply chain questions that are left to be answered. And there's still the same basic questions that we've been trying to answer for several years. We just want to be able to become better at answering those particular questions faster. And that is, number one, what are the impact that these technologies are going to have on my supply chain management capabilities, and not qualitatively, but from a very finite quantitative aspect. What will the impact be on days of held inventory? What will the impact be on time in full to specific customer segments? How much flexibility will I have in my supply chain if I'm able to bring in new technologies? What's the delivery window certainty if I switch from manned trucks to a autonomous truck that is able to make deliveries on my behalf without a driver? Will that impact my OTIF rate, or will it impact my delivery window? And how can I be sure to be able to understand these impacts before I've implemented them? So that's really still the crux of the issue that we're faced with today. And that brings us to our first poll question, which is really, what questions are the most important to you still today? And while we didn't cover all of them during the last particular session, or last slide in terms of the discussion, I still think we have enough of an answer and a realization to go ahead and request the question. Secondly, and more importantly, the old Darwinism saying of only those that are able to adapt the quickest will survive the longest still comes to fruition today and in this particular day and age with these technological changes. So we'll go ahead and take a look at the results of these particular questions. And it looks like, how can I quickly find problems and identify root causes is still the leader, as well as how can I a tie for second place between the impact of understanding new technologies and understanding how my supply chain is supposed to operate. And that's usually pretty typical of what we see, especially when you consider identifying problems and root causes. The time to do that is typically the critical factor that's sought out. It's not that organizations aren't able to understand what's driving their KPIs, what the root causes are in terms of the issue. It's the amount of time and man hours that are spent doing that. And that's a topic that we're going to cover in detail today, especially with the understanding of how's my supply chain supposed to operate. And then we're also going to cover, how do I understand at that granular level what the impact of those new technologies will be on my supply chain, and how can I do that with certainty? So I'm glad that those three questions were the immediate or the top rated ones, and without further ado, we'll jump into how we go about doing this. There are three real capabilities that are required in terms of answering all of those questions and being able to transform a supply chain. The first is being able to understand, what is my company's business strategy, and do I have it written down somewhere? More importantly than having it written down, is it in a manner that I can actually use, that I can leverage to plan KPIs against, that I can leverage to guide supply chain execution and planning processes, that I can tie exactly how I want my supply chain to operate against a tangible business value template. And that's taking something a step lower than, say, a nice mission statement that sounds well and good, but really looking at what's important to the company, how is this documented, and how is this continually integrated into my my process modeling and supply chain execution planning tasks. And that comes to the second capability, which looks at defining how those end-to-end supply chain processes are supposed to work. And by creating that particular definition, a company understands how do I want to operate. And that operations will always change and flux by business unit, by region, sometimes even by SKU and customer. But being able to have that core baseline that's used and created based on operational requirements is central to being able to answer those particular questions. That can be done by either getting a group together and saying how we want our supply chain to operate and modeling it out, leveraging the assistance of a consulting firm, or using a template such as the supply chain operations reference model that has executable processes created that is a good point for a company to start with, get started quickly, and then be able to leverage that information and make it their own. And it all depends, again, on a company's maturity. Or, since most companies have been practicing supply chain management best practices for years, what if I leveraged and began to understood how my processes are actually executing today without designing them, but understanding what are my capabilities, what are my constraints, and what happens once I receive an order, or what happens once I create a PO, or what happens once I want to execute an S&OP process. That data can then be used or gleaned from those as-executed processes and used as a baseline so that the as-is process, how you're actually executing your supply chain, is used today as that model. And that, of course, allows for the entry of those KPIs, as well as supporting technologies to be included straight away. And then thirdly, being able to identify actual capabilities, actual capacities based on real usage. Again, being able to analyze what's occurring in my supply chain to pinpoint that root cause based on not only rearward-looking KPI data, but also being able to analyze performance that drove that KPI, and then being able to understand and define what changes I want to make and simulate those changes before I implement them. And those changes could be something such as a global center of excellence, implementing process changes. It could be something such as I'm implementing, or I want to implement a new warehouse management system. How will that impact my supply chain execution capabilities? Or it could be something as large as I want to understand if I am creating a new distribution center network, what impact will that have on inventory and service and process cycle time? And it's those last two areas, model and segment, as well as analysis and simulation, that comprise a relatively new concept. And that relatively new concept is titled the Supply Chain Digital Twin. And it's a key aspect of being able to transform supply chains at a faster rate than previously realized or previously needed. And again, going back to the new technology requirements, with the rise of the additional technologies also comes a rise of higher expectations. And that's driving that particular requirement to really push and understand how can I model, test, and simulate my supply chain in the back office, but in the back office based on how I'm actually executing consistently around the world. And then lastly, of course, this particular process isn't linear, it's fluid, and continuously loops back to ensure that you're able to continuously improve your supply chain over time with that same guide. So the real question is, what exactly is a supply chain digital twin? And the best example, or I shouldn't say the best, but a relatively straightforward example is looking at a person. And as a person that's running, I want to understand exactly what's going on in my body right now as I'm exerting myself. So as I went out for my run this morning, I happen to also have one of these wonderful devices, and it tells you exactly what happened during my run. It gave my heart rate, it gave the amount of time I spent running, it gave the amount of steps that it took to cover the miles that I ran, and it gave a nice visual display based on GPS of where I ran to and from. It was wonderful. Where it falls short, where a digital twin connects, is the ability to say, if I changed my speed and increased my speed, what would that impact be on my heart rate? What would that impact be on my calories burned? And that's really where the enterprise digital twin comes into play, which is, what's my supply chain reality that I'm dealing with today? I want to take all of that information and I want to be able to create a twin of that allows me to manipulate it and ensure I'm able to really push forward and test not only strategic changes, but also how my ecosystem will respond to changes that I make or changes I'm requested to make, what technologies are able to be changed, or what impact will technologies have as I introduce them, as well as how can I fundamentally get better at managing my end-to-end supply chain. And that's a brief overview of how that digital twin works. What's critical to remember about a digital twin is that it spans not just the end-to-end supply chain, but really the end-to-end value chain. And going back to that first article on the death of supply chain management, what we'll see is supply chain professionals will become much more fluid in areas that they've understood previously, but now will have a much larger focus on with new jargon. So instead of customer supply chain integration, it'll be looked at customer experience, which a term that's been around, that's been used by marketing and sales for years. But now supply chain professionals are going to be using that because they're going to have the power to tap into this digital twin of how their supply chain runs and understand what changes they will have on that customer experience. Additionally, how can I understand what risks my supply chain is taking, both from a regulatory and event-based perspective, and how can I simulate the impact of risk that could occur around the globe, and more importantly, how am I able to control the quality of output of the responses of the work that's being completed by supply chain participants, by my ecosystem that's supporting me as I make and deliver products to my particular customers. And then, and perhaps most critically, how can I ensure that I'm continually better aligning with IT so that as new technological capabilities are introduced, some of which we haven't thought of or heard of yet, how can I ensure I'm able to guarantee that those particular capabilities are good for my supply chain, simply because not all capabilities are really needed for everyone. And a nice example I can give is, let's talk about the Internet of Things. IoT has been heralded as a panacea for everyone that will give visibility into deep, dark corners that visibility wasn't needed before. And if you're shipping temperature-sensitive medications or produce or components that are sensitive to vibration, then absolutely, the Internet of Things will provide great visibility in transit into those particular uses, and it's absolutely needed. But what if you're a company that's shipping pallets? Do you really need to understand the temperature, the vibration of those pallets en route? The location might be helpful, absolutely. But your use cases in terms of how can I derive value are significantly shrunk. But if you're able to simulate that particular impact on your supply chain, on your KPIs, then you can say with certainty, hey, if I'm a pallet manufacturer and I'm shipping pallets to my particular customer, and I'm able to leverage IoT to gain visibility, I'll be able to make deliveries X amount faster with X amount higher rates of on-time capabilities, which means my customers will have to carry less pallets in terms of safety stock to keep their plant running, then they're set. The ability to control those KPIs can be brought out quickly and easily. So what are the key drivers in terms of why someone pursues a supply chain digital twin? And first and foremost is the companies that we've worked with that have pursued this initiative want to really understand what's happening across their entire value chain and ensure that their supply chain is functioning inside of that value chain as required. And they want to be able to disseminate information quickly and easily and be able to identify root causes and share those root causes with the right people to get the job done quickly. Secondly, they want to make sure that as actions are taken, the value for those actions is maximized, meaning specifically they don't want to miss cutoff times. They don't want to miss specific due dates to obtain value, or they don't want to suboptimize the manner in which they make that particular value. And that's where, again, being able to understand how my automatic exception management will work and how I want it to work based on simulation of that supply chain digital twin comes into play. And then lastly, but perhaps most importantly, is how can I gain better control over my entire ecosystem? And that includes my supply chain partners, it includes my customers, it includes all providers, so that I understand comprehensively what impact they're having on my supply chain today. Are they helping? Are they hurting? And how can I provide that information to other groups that need that information, such as if I'm a supply chain manager and I'm having consistently late deliveries from a particular product vendor to a specific plant, what impact is that really having on the end-to-end supply chain? And what's the cost? And that's really where that derivation comes into play, by being able to take the as-executed end-to-end process and understand how I would be able to improve it based upon, say, a delivery window that's consistently met by a particular vendor to a particular location, and I can do that quickly and consistently, then I'm able to make a real impact with a minimal amount of time, as well as being able to make that impact as quickly as possible. So when we're looking at these expectations, requirements, and outcomes, we've worked with many different manufacturers around the globe, and they seem to have very consistent requirements in terms of focusing on how do I just get better in terms of performance. And again, our poll question hinted at this as well. How do I get better management, and how do I have an easier time of finding root causes and being able to mitigate or improve upon those particular issues? They also have similar desired outcomes: get better at delivering to our customers, become more profitable, get more revenue. Again, it seems when you go to a high enough level and you're talking about these sorts of outcomes, everyone's typically the same. However, the real challenge is each manufacturer has their own technical challenges and requirements, which means really that a one-size-fits-all type of approach or solution won't work. That the technical nuances of the solution itself have to be able to be extraordinarily flexible and modular to be able to, again, capture that time to value and be able to realize that value as quickly as possible. And that's where we're just going to spend a few minutes talking about how this works. And as always, it starts with our current systems of record. And those can be our current supply chain execution systems that include WMS, TMS, ERP, any sort of planning tools that we have in place that house data. And typically what we've seen is companies will take that data and they'll want to mine it. So they'll drop it into a database and perform deep learning to understand what's going on historically with their performance. Additionally, that data needs to be shared, and we've seen the rise of cloud-based collaboration hubs allow for that to occur, so that data can be shared with a litany of companies and done in the right time to allow all companies in the ecosystem to begin taking action. But in terms of how do I go about transforming the supply chain, we want to first focus on, again, being able to either discover or document your as-is and to-be processes. And that can be done through either process modeling, a collaborative analysis proposition in which multiple people are completing that, or it can be done through intelligent discovery of how my processes are fluidly working. And during that intelligent discovery process, I want to be able to identify monetizable improvements so that I can fundamentally transform how my business functions. And by automating that on a continuous basis and pulling that data out of my execution tools, I'm able to, again, begin creating that digital process that digital process twin that prepares me for the fundamental transformations that I'm going to undertake. And that's, again, not a one-time project. It's something that's going to occur as part of our daily lives in terms of being supply chain practitioners, that instead of focusing on the we'll call it customer service firefighting or ensuring that issues are continuously mitigated, the roles are going to be focused on how do I ensure I'm able to have technology perform the firefighting work for me while I work alongside technology to perform this deep analysis. And one of the outcomes of the continuous improvement work will be, again, cleaning up those KPIs to be able to monetize the events that are found in real time. Secondly, and most importantly, is the ability to really look at what's happening now. How do I look at my end-to-end supply chain, identify exceptions automatically, and then obtain that ever sought-after real-time visibility that's going to come from a myriad of systems, whether it's my order management system, whether it's a IoT sensor, or whether it's a production line sensor that I need to understand what is actually coming off the end of my production line so I can push it into available to promise sooner rather than later so that I'm able to better optimize my inventory, is all being monitored as well as continuously evaluated and even fed into predictive models that we talked about earlier. And that's where the automation of those particular processes is going to get very, very smart, with closed loop analytics being able to define and understand if X action is occurring, then I don't necessarily want to go down my set path. I want to push down another path simply because I've been given options and I want to understand how the environment, how my external issues are impacting the options that I have that are able to be taken at this particular time. And then lastly, I want to be able to share all of that information that's able to be tailored for particular SKUs, regions, business units, customers, and suppliers, both internally as well as externally, to be able to ensure that no one is not taking the right action because of lack of data. And this brings us to our next poll question, which is, what impact do you think new technologies will have on your performance today? And some of those new technologies, again, we talked about earlier, it could be one that wasn't listed. Again, we use the Internet of Things as an example, artificial intelligence, machine learning, robotic process automation, predictive analytics. But out of the brief 5 questions there, where do you think the value will lie? And we'll go ahead and move on to the next answer just to see what we've got. Getting reliable data from multiple supply chain execution and planning systems. All right. That's always the crux in terms of how do I get reliable data now from what I have. And it's a critical component that we talked about during the previous architecture in terms of putting together data and processes across multiple systems to come up with something that's fluid and usable. And we have a customer case study that we're going to cover in terms of a food and beverage manufacturer that had that particular issue. Specifically, they had that particular issue with a large number of systems across their entire global value chain. And while we did cover the previous capability architecture and discussed exactly how that would function, like everything, there is a maturity curve to implementing and really future-proofing your supply chain in terms of an optimization perspective, as well as providing a digital twin of your supply chain. And the first focus is, again, on how do I gain that base on understanding? How am I able to model and design what I want to have happen as I enter into new markets? What capabilities can I create from a customer or supplier segmentation perspective, and then how can I begin this process by discovering, rather than modeling, how my processes are executing today. The second step along the maturity curve is, after I have my base taken care of, I want to begin being able to analyze what's happening in real time, so that I can look at both exceptions as they occur to kick off exception-based processes. But I also want to perform root cause analysis that includes, at this point, looking at my end-to-end value chain and being able to benchmark my best performers against my worst performers inside of my organization, so I can understand what's driving the best performers, what's holding back the worst performers, and how are either one deviating from what I consider to be the corporate standard of how we want to execute and go about doing business. The third part is when it starts getting fun, real fun, and that is adding the advanced technologies that we talked about. So think of steps 1 and 2 really as making sure my house is in order, making sure that I'm organized, that I'm forward-thinking, that I have the ability to manage what's happening before I begin innovating. And then I'm able to layer in the more advanced analysis that we talked about, because I'm able to define and understand where that fits and the exact value it will provide, as well as what I can expect the impact to be on my supply chain. And then the last and final step is intelligent automation. And that's where when you look at, for example, artificial intelligence, complex event processing, and predictive analytics, they really work well with intelligent automation. In fact, while the intelligent automation should come post the implementation of any advanced analytics, it's a very, very close second, because that really unlocks the value of that of any sort of analysis that's occurring, because you're able to take action before deadlines are hit. You're able to have actions taken faster and at better speed than most people can manage, as well as you're able to have large numbers of actions taken without having to dissect information in terms of what's happening right now. And that's the real difference in paradigm. Again, going back to that Harvard Business Review article, is as supply chain control towers have been set up, there have been wonderful examples of companies that have built war rooms with monitors all around in terms of a room, and being able to look at and see what's happening now. The reality is that that's difficult for people to constantly process at scale. And the reality is that as supply chains expand, you really have to be able to have machines being able to perform that analysis and generate those exceptions, and generate those exception management processes for you straight away. So again, while you move up this maturity curve, it's an iterative process that continually folds back upon itself rather than a linear process. As you begin to intelligently automate exceptions, again, that gets brought back into, how is my supply chain model fundamentally changing? How is my end-to-end value chain model fundamentally changing to work with that? So we have 3 customers that we're just going to use as brief examples. The first is a global food and beverage manufacturer, and they had some issues in terms of understanding what their systemic data is and how to pull that particular data from their numerous applications. A medical devices and healthcare manufacturer that was focused on being faster, being nimbler, being able to cut inventory while improving on-time and full levels. Excuse me. And lastly, a multinational conglomerate that makes everything under the sun that you can believe, but they just wanted to focus on not a end-to-end analysis perspective, but they wanted to focus on how can I just be able to get better at responding to requests? How can I better control that particular process and make it faster? Well, the first particular issue that one of our customers came into was the lack of a single point of truth between multiple order management processes as well as the requirement to really manage their more than 50 ERPs around the globe and untold number of supply chain management applications. They had to be able to pull data out of that, and that was the first key technical hurdle. For the healthcare and medical device company, they really wanted to focus on how do I get simpler. I have a huge complexity involved with understanding exception codes. I'm really not action-oriented. I have exceptions coming and finding users instead of being able to identify root cause, being able to identify exceptions and attack them. And I also don't have the ability to understand what's really happening across my organization. So my reasons for not being able to do this are becoming facts, which wasn't exactly a great thing. So what did these particular companies do is they looked at, number one, I want to be able to automate and be able to pull data out of my 50-plus ERP systems, plus my supporting supply chain execution systems of record into a single hub of truth. And that comes, again, to that supply chain digital twin. How do I understand how my processes are functioning, how those are being able to reveal themselves and support my KPIs? And then secondly, for the healthcare company, how do I understand where my bottlenecks exist? How do I determine root cause, and how do I direct action based on region, customer, SKU, business unit, and how do I remove those excuses? And they were able to complete that by directing action, and again, by being able to pull out data that was housed in their execution systems that they previously couldn't get to. And then for the healthcare company and medical device company as well, how do I ensure I'm able to integrate this with my current logistics and supply chain partners so that they understand the impact that they're having on my business, and I'm not creating monthly scorecards. I'm not sitting down for monthly or quarterly business reviews, and that's the moment of truth, but that there is constant and continuous feedback so that we're all continuously operating with each other and moving to the beat of the same drum all at once. So for these three particular companies, what were their outcomes that they realized for this? Well, for the food and beverage company, they were able to increase their global to promise policy while significantly reducing their inventory day sales. The medical devices and healthcare manufacturer was able to increase their profit margin by a little bit more than 25%. They decreased their go-to-market complexity by 94%, while increasing on time and full to levels higher than 95%, because they were able to, again, obtain that information and identify those root causes quickly, easily, and identify bottlenecks or error rates. And then for the multinational conglomerate, they just wanted to focus again on how do I respond faster? And they were able to do this by understanding how their response processes were functioning, and they were able to reduce administrative times by 3 days per month and reduce response times by 5%, which was a very, very large number for them considering the scale of their particular organization. So while those were selected outcomes, typical benefits that are seen from really being able to obtain end-to-end visibility, creating a digital supply chain twin for an organization, focus on being able to respond faster to market conditions with more certainty, being able to understand how businesses function, the interdependencies between the multiple silos and applications, whether it's on a business unit, regional, or SKU level, being able to provide better outcomes from the supply chain to customers, whether those are internal customers at manufacturing facilities, whether those are external customers, and being able to do that in a more efficient manner. And then lastly, and we touched on this earlier, being able to implement new technologies faster. And those new technologies could be something such as I need to renew my ERP system, or I'm implementing a new WMS system. But they can also be, again, some of the leading edge technologies that we discussed as well earlier, such as I want to add predictive analytics to my supply chain and be able to do continuous demand prediction. How can I ensure I'm able to implement that as fast as possible on a global scale? And that's where that visibility and simulation comes into play. So thank you for joining me today. I hope you found this webinar educational. We have Software AG has created the world's first digital business platform, and it focuses on many of the technologies that you have heard on that we talked about today, which is how do I transform my enterprise? How am I able to make use of new technologies, and how do I ensure that I'm able to keep that as flexible as possible from where I want to deploy? So that being said, I'll say thank you. I appreciate the time, and thank you, John. If there are any questions, we're happy to answer them.
Thank you very much, Sean. We'll now address questions submitted during the discussion. again, simply use your ON24 control panel to submit questions to our panelists. Sean, our first question is what the team structures typically used for creating, managing the digital twins? Is this a unique functional group within supply chain, or is each function within the supply chain having some responsibility? In other words, who owns this, and how large is this team typically?
So it's a very good question. I'm glad it was asked. So typically, it's not an extra organization that owns the digital twin. You'll typically have multiple organizations with their pardon the euphemism, but with their hands in the pie. So you'll have a global center of excellence that will be in charge from a process ownership standpoint. You'll have your supply chain operational teams, whether it's groups of supply chain managers, whether it's the innovation team from under a specific supply chain segment, or whether it's logistics or distribution professionals, will also be part of this particular function. And the reason for that is while it's a singular concept, every group has a different input to the digital twin as well as a digital output. And what I mean by that is, for example, we might have the Global Center of Excellence that owns and approves final changes to processes as they're executed. And someone from IT operations that's supporting warehousing says, hey, here's the new WMS system that we're implementing. Here are the recommended process changes to how our warehouses are going to function based on new WMS functionality. And that's all shared, not via email, not via documents, but that's shared via changes that are made to a digital twin. And the COE has the ability to look and approve, disapprove, modify those particular changes or collaborate in real time while the group is looking at the same single source of truth on that particular piece of data, so that they're able to, again, align and understand the impact of those particular changes or requests on data. Similarly, you'll also have business executives with their hand in the pie as well, because they're receiving KPI information in terms of outcomes. And those outcomes can either be stakes in time, so a traditional report, or it can be a real-time discussion on what's happening right now in terms of performance. And that's why there isn't a new group that's created to own this, but it will blend itself into the everyday lives of groups that already exist today.
Right, thank you, Sean. Our next question is, how do you determine how your current supply chain processes are executing, and is this created manually?
Another good question. So you determine it by completing a process mining endeavor. And really that's where part of the functionality of a supply chain digital twin is the ability to go into the multiple systems of execution to pull out of any master data tables what expectations are, what measurements are, and create a end-to-end process. Now, it's not pure magic, and the first time this occurs, there is some rationalization assistance that's required from a visual manipulation standpoint, but obtaining the underlying data, obtaining how this particular how you get that data is a automated process, and it continues to be an automated process. So for example, the food and beverage manufacturer that we referenced earlier, they pull master data table figures to update their as-is parameters once every 2 weeks, as opposed to the medical device and healthcare manufacturer. They pull master data information alongside, or I should say, to augment their as-is process mining 3 times a week. And then, of course, they pull actual execution in real time. So as processes are being kicked off throughout the supply chain, that information is constantly being analyzed and modified. And they're pulling from for example, the ERP tables and the master data tables on a more sporadic basis, just to ensure that they're still aligned and there aren't any changes that need to be made to those ever critical tables.
All right, great. Well, we had time for just one more question. Briefly, if I simulate a proposed change, what results will I get?
You'll get the exact same results that you're measuring KPIs for. So typically, I want to look at cycle time duration in terms of process steps. I want to look at my rearward-facing KPIs, such as on time, in full, inventory, time to serve. But you'll also get outcomes in terms of how much capacity do I have if I make this particular change. What can I do with my current capacity? How much time will this spend on a truck? How much time will this spend in a distribution center based on process step, based on the parameters that I'm simulating in terms of either forecasted customer orders or historical customer orders. So the short answer is the KPIs that you're looking at in terms of measuring your supply chain today will be the KPIs that will be outputs from the simulation.
All right, thank you, Sean. I want to thank our audience for joining us. Our panelist today has been Sean Riley, Global Industry Director, Manufacturing, Supply Chain, and Logistics for Software AG. This is John Yuva, Editor for Supply and Demand Chain Executive and Food Logistics. Have a great afternoon.